In this video, I am going to explain the experiment, the thermal expansion of metals. The objectives of this experiment are to investigate the relationship between a change in length and change in temperature of two different materials, aluminium or copper. That means we are going to study the relation between delta L versus delta T. By using the relation between delta L and delta T, we are going to find the value for linear expansion coefficient. What is linear expansion coefficient? Which is nothing but alpha. In chapter number 18, we studied the concept of thermal expansion. So in that thermal expansion, we studied three different expansion formula: linear expansion, area expansion, and volume expansion. So here we are going to study the concept of linear expansion. The linear expansion relation is given by the rule delta L, which is equal to alpha multiplied by L naught multiplied by delta T. So here this alpha is nothing but the linear expansion coefficient. For today's experiment, we are going to use either copper or aluminium rod. So for that, you will get the answer for its respective alpha value. So let's see the chart here. So this chart shows the value for different materials alpha value. For example, if you see the aluminium material, the alpha for the aluminium is 23 multiplied by 10 power minus 6. The value for the copper is 17 multiplied by 10 power minus 6 per Celsius degree. So here in this experiment, after you complete the experiment, suppose if you use copper, then your answer should be closer to 17 multiplied by 10 power minus 6. If you use aluminium rod, then your answer should be closer to 23 multiplied by 10 power minus 6 per Celsius degree.
The apparatus used in this experiment are, we are going to use a water bath and we fixed a temperature controller here. We can set different temperature in this controller, but for today's experiment, we are going to take the data starting from the temperature 30 degree to 60 degree. And here we fixed a thermometer. The purpose of the thermometer is just to check the temperature of the water again. For example, after you set 30 degree, the water will heat to the temperature, but we have to check the temperature of the water again by using this thermometer. And then we have to use this aluminum rod. Actually, we have two different material. One is copper, one is aluminum rod. So the main objective of this experiment, we are going to find what should be the thermal expansion coefficient for this aluminum rod. As we already studied in chapter number 18 about the linear expansion, right? So that formula we are going to use in this experiment, and we have to consider the original length of the rod here as 600 millimeter. And other side we fixed a dilatometer, and this dilatometer is going to give the information about a change in length happen in this rod. For every change in temperature, what will happen? So the water, after the water reach the temperature, the water will be flow through this aluminum rod, and once the hot water is going through this aluminum rod, that temperature will be given to this rod, and based on that, the expansion level will be indicated in this dilatometer. So here each line is 1. Okay, so for example, you can see we have to set the pointer at 0, and if the pointer goes to the line 2, so we have to say 2 multiplied by, and the number is given. So we have to find the change in length in terms of millimeter. So after this pointer reach some number, and this number multiplied by 0.01. So you can see I already magnify the portion of this number. So you can see, so the number what the pointer shows multiplied by 0.01, and that value you have to record in the data sheet paper. Clear? So these are all the apparatus today we are going to use.
Okay, now we have to see what is the theory we are going to use in this experiment. The theory used in this experiment is nothing but the linear expansion relation. As I already mentioned earlier, the linear expansion relation is given by delta L, which is equal to alpha multiplied by L dot multiplied by delta T, where delta L is the change in length, where delta T is the change in temperature, where L naught is the original length of the rod or material. By using all these things, the main objective of today's experiment, we are going to find the value of alpha. Clear? So you have to rearrange this equation in terms of alpha. When you rearrange this equation, your equation will be modified like this. And now we have to see how to take the data in the data table. So if you see this slide, we are going to fill this table, and before we fill the table, we have to see what are the informations we have to return here. So first of all, before you start heating the water, we have to find what is the initial temperature of the water, because generally we will fill the water bath with cold water, right? So the water temperature, the initial temperature of the water, before you heat the water, we have to find what should be the initial temperature of the water. Suppose the water should be 22 degree or 23 degree, am I right? So that value you have to take. So if you turn on the device, what will happen? The water will reach the temperature. So it will be really very hard to find what is the initial temperature of the water. So the first step, before you turn on the device, what you have to do, you have to take the temperature, the initial temperature of the water, by using a thermometer. And the second important thing, which material you are going to use, whether you are going to use the aluminum rod or copper rod. Both rods are exactly in same length. So the initial length of the rod for both aluminum or copper is exactly equal to 600 millimeter. Clear? So the L naught for both aluminum and copper, we are going to consider the initial length as 600 millimeter. Now we have to fill this table. So what I am going to do, I am going to show you a separate video how to fill the data by using the apparatus. Clear? So when you saw that video, you will get a clear idea how to take the data to fill this table.
Now I'm going to explain how to fill the data in this data table. Before that, we have to read the information which is given in the top of the table. So first of all, we have to find what is the initial temperature of the water. So before you set this temperature 30 degree, we have to find what is the initial temperature of the water. So here we have the water bath. This water bath is filled with water and we fix that thermometer. So now I'm going to find the initial temperature of the water by using this thermometer. So I will just magnify it. You can see each line in the thermometer is 0.5. So that means here 20, 20.5, 21, 21.5, 22. Clear? So I have to write this value here. The initial temperature of the water is 22 degrees Celsius. And here we have to write what is the original length of the rod. As I already mentioned in the previous video, we took the initial length of the rod is 600. Anyhow, I will show here. So you can see the rod, what we are going to use for this experiment is this aluminum rod, and you can see the range we are going to consider from 0 to 600 millimeters. So the total length of the rod here we are going to consider is 600 millimeter, and that value is written here. And also one more important thing, we have to set the dilatometer. So this is our dilatometer. This dilatometer is going to give the information about the change in length happens. Am I right? So suppose if the needle is in different number, we have to turn this black color. You can see in the side we have that turning knob, and by using this we have to set the pointer to 0 exactly. Clear? And then for calculation we are going to use the linear expansion formula, delta L, which is equal to alpha L naught delta T, and we have two materials. If you see the material what we are going to use for today's experiment is aluminum. So we have to tick this one because we have two different materials, but for today's experiment I'm going to use the aluminum material, so I just strike out the copper. Now we have to take the data for this data table. So first of all, we have to set this temperature in the temperature controller, and before that we will check the dilatometer. I think it is exactly at 0, right? So again I will 0. Now I am going to set 30 degree I'm going to turn on. When you turn on the device, you can see here we have two lights there, right? The first one is green and the second one is yellow color. Once the water reach the temperature of 30 degree, what will happen? The second light, the yellow light, will turn off. It will be off. So once this light will off, it shows that water reach that temperature. When the water gets the temperature, what will happen? The water will be circulating through this hose, because we connected this hose with this aluminum rod. That means the water will be keep on circulating in this rod by using this hose, am I right? And what will happen? That 30 degree will be given to this aluminum rod, and because of the temperature, you can see the dilatometer will change. You can see previously we set 0, right? Now what happened? Because the hot water is flowing through this pipe of aluminum rod, and that change in length is exactly indicated in this dilatometer. So now what we have to do? We have to wait until the yellow color light will be off. Clear? Once this light will turn off, we have to take the data from the dilatometer. Now you see here the yellow light is off now, right? That means the water reached that temperature. Which temperature? In the temperature controller we set 30 degree, right? So now you have to check whether the temperature is exactly 30 degree or not, because you have to see the paper. After you set temperature dialer temperature as 30 degree, we have to check the water temperature again, because we don't know whether the water is exactly reached the temperature or not. For that purpose, we attach the thermometer here. Clear, brother? So now what I'm going to do, I am going to measure the temperature of the water again, because here the light, you can see it will be blinking now. Even if it start blinking, means that says the water almost reached the temperature. So now what I'm going to do, I'm going to take the temperature of the water again, because we set 30 degree. Now you can see it's not exactly 30 degree. Am I right? So it was almost 29. So that's the reason we have to measure the temperature of the water again. So now what I'm going to do, I'm going to write the value of the temperature of the water. We set 30 degree, but now what is the temperature of the water? 29 degrees Celsius. And also we need the value of delta L from the dilatometer. So the water reached the temperature of 30 degree. Now we have to check what's the value the pointer shows. Now you can see it's exactly between the point 12 as well as 13. Am I right? If it is exactly on line, please write that number. But here I think it's almost same, right? So that means the pointer shows the value of 13 or maybe no, it's not 13. It's between 12 and 13. So we have to write the least number. So what I'm going to do, I'm going to take the data as 12, but that 12 should be multiplied with 0.01. You have to see here, you have to multiply this number with this pointer. So here we have 12 multiplied by 0.01. So I have to write 12, the pointer shows, but we have to multiply with 0.01. So what's the value here? 0.12. Clear? So for 30 degree we set in the temperature controller, but after the light off, we check the water again. We check the temperature of the water again by using the thermometer, but the thermometer shows only 29 degree, and for that the dilatometer gave the value of 12, because the point is exactly at 12. Actually it is between 12 and 13, so we have to take the least value, but that number should be multiplied by 0.01. Clear? So likewise what you have to do, after you complete the first reading, we have to set the temperature 35. So what I'm going to do, I'm going to set the temperature as 35. Now the temperature is different, right? So again you can see when you set 35, two lights on now. Now once the water reach this temperature, this yellow light will be off. Now what you have to do, you have to take the temperature of the water again, because why? We set 35, but the thermometer will give you different value. Why? Because this is just a device, right? So sometimes the temperature what we set for the water will not be exactly the same value. Sometimes it may be more, sometimes it may be less. So you can see after the water reach this temperature, this yellow light will be turned off, and then we have to take the temperature of the water again, and then you have to write what value the thermometer gave after the light off. You have to write this value, and then you have to take the delta L from the dilutometer, because for sure the dilutometer will be keep on moving because the temperature now it's increased. So whenever the temperature is increased, what will happen, the change in length will be happen, and that change in length is indicated in this dilutometer. So likewise, what you have to do, you have to repeat this experiment for different temperature, and likewise you have to take, after you set the temperature, one more time you have to measure what is the temperature of the water by using the thermometer, and then you have to take the data from the dilutometer delta L. So once you complete everything, then you have to get ready for drawing the graph for this experiment, and from the graph you are going to calculate the slope, and after you calculate the slope, we are going to use this equation alpha, which is equal to delta L over L naught delta T. So this delta L over delta T, you are going to draw the graph between delta L and delta T. So this value should comes in y-axis, and this delta T should comes in x-axis, and you have to plot the points after you fill the table, and you have to calculate the slope, and here the slope here is nothing but delta L over delta T. Am I right? So once you substitute the slope, and L naught is the original length which we already measured here. Clear? So likewise you have to complete, and this is the explanation how to fill the data.
Yeah. After you fill the data in this data table, we are going to draw the graph between delta L and delta T. That means after you fill the data in this data table, delta L should comes in y-axis and delta T should comes in x-axis. So for that we have to draw the graph. So better I am going to draw the graph in this slide. So I have to draw the graph by drawing the line for y-axis, and in y-axis what we are going to take, we are going to take delta L. So this delta L is initially in terms of millimeter, but later on when you are going to find the answer for alpha, by the time you have to convert this value to meter. And in x-axis we are going to find the value, we are going to fix the value of change in temperature. So the unit here is Kelvin or Celsius degree. So what you have to do, by using the values of delta T and delta L, we are going to fix the values in the given graph. So by that you will get these type of rising points. So you have to connect the points by using your ruler. Some points might become outside the line, so you no need to worry about these things. So if any points comes out of the line, no problem. So we have to calculate the slope by using any 2 points, and that 2 points must sit on the line. So let's we take these 2 points. If you see these 2 points, these 2 points are exactly on the line. So I am going to take the slope for these 2 points. So let's we take x1 value here, and this will be our x2 value, and in y-axis this is our y1 and this is our y2. Now we are going to find the slope. So what's the formula for the slope? The formula for the slope is delta y over delta x. So what is your delta L, delta y? In delta y, that is our y-axis, we took the value of delta L. In delta x, we took the value of delta t. So that means the slope answer is exactly equal to delta L over delta t. Now I am going to substitute the value. As we know, delta y is nothing but y2 minus y1 over x2 minus x1. Once you substitute the value in this y2 minus y1 over x2 minus x1, you will get the answer. And this answer is exactly equal to delta L over delta T. And the most important thing, you have to write its respective unit. So in y-axis we took delta L, so its unit is in millimeter. So later on we have to convert to meter. So meter divided by Kelvin is the unit for this graph slope, right? Now by using this slope, we are going to find the linear expansion coefficient value alpha. So for that I have to take the relation of linear expansion, which is delta L, which is equal to L naught alpha multiplied by delta T. We have to rearrange this equation in terms of alpha. Therefore alpha, which is equal to delta L divided by L naught multiplied by delta T, right? It's not alpha because we are going to find the value of alpha. So alpha, which is equal to delta L divided by the original length L naught multiplied by delta T. So here delta L over delta T is nothing but our slope. So what you have to write? We have to write this equation as slope divided by the original length, which is equal to alpha. Once you substitute the value of the slope here, and after you divide that slope with the original value, the original length of the rod, we will get the value of alpha. What is this alpha? This alpha value is nothing but the experimental alpha value. And what's the unit? The unit here is nothing but 1 over Kelvin or Celsius degree. Clear? So now what we have to do, we have to compare the answer of our experiment with the standard value of alpha. As we already know from the chart, the standard value for alpha for the aluminium, which is equal to 23 multiplied 10 power minus 6 per Celsius degree or Kelvin, and the standard value for the copper, which is equal to 17 multiplied by 10 power minus 6 per Celsius degree or Kelvin. Now these two are a standard value or actual value, and the answer what you get from the graph is nothing but your experiment value. So your answer of your experiment should be closer to the actual value. Clear, brother? So for that we have to find the error percentage calculation. As we already know, the error percentage formula is given by the rule absolute value of alpha by experiment minus alpha by actual or standard divided by alpha with actual multiplied by 100. When you substitute your experiment value here and when you substitute your actual value, so these two are actual value or standard value. We can write it's a standard value of aluminium and copper. Once you substitute this value, you will get the error percentage, and for sure if your error percentage is between 1 to 10%, then we will consider your answer. So in this way you have to do your calculation for this experiment. So this is the explanation for this experiment, thermal expansion of metal. Thank you.